This video tutorial will solve AP Chemistry free response question number 4 from the 2013 exam. Before we proceed, it's worth talking about question 4, which always follows the same format on the exam. You'll be asked to write a balanced chemical equation and then answer a follow-up question briefly about that chemical reaction. There are some assumptions that are important to this question. First of all, assume all the solutions are aqueous and everything occurs as an ion if it's extensively ionized. Second, any spectator ions, things that do not react in the reaction, things that are unchanged in the reaction, can be omitted. So any spectator ions are not included in your final answer. All right, let's move on to question subpart A. 20 mils of 0.1 molar potassium phosphate are added to 30 mils of 0.1 molar calcium chloride. So you need to know your polyatomic ions for a reason, and this question is the reason. What is potassium phosphate? Well, potassium is a +1, phosphate's a 3-, so there's potassium phosphate. Same for calcium chloride, CaCl2. They're going to react, form a precipitate, and something else in solution. So the precipitate is calcium phosphate. Calcium, again, a 2+, phosphate, a 3-. So you need 3 calciums and 2 phosphates to have the charges balanced in that ionic solid. And then there's a bunch of KCl left over. However, potassium is always soluble. It is always a spectator ion, so the potassiums and the chlorides are not included in your final answer here. So what's the final answer? Well, it's going to be, I'm sorry, I didn't balance the equation, did I? I've got 3 calciums here, so I need to put a 3 here. That gives me 6 potassium chlorides. That means I need to put a 2 over here in front. Now you can bring all this up to the final answer. You have 3 calcium 2+, and 2 phosphates. Sorry, that's a 3-, yield your product, calcium phosphate. Second part of the question, how many moles of the product are formed? Well, you have to figure out how many moles of each ion are present. So for the potassium phosphate, we had 0.1 molar and 20 mils, or 0.02 liters. That's 0.002 moles. For the, what was it, calcium chloride, we had, sorry, that's a CaCl2. We had 0.1 molar and 0.03, 30 mils. So you get 0.003 moles of calcium ion. Now, notice the mole ratio in the total number of moles we have present. It's 2 phosphates for every 3 calciums. And notice the mole ratio we have in the balanced chemical equations, 2 phosphates for every 3 calciums. So we have the precise mole ratio, except in this case we don't have whole numbers of moles, we have thousandths of moles. So the total number of moles of product formed is going to be 0.001 moles of your product, calcium phosphate. Subpart B of the question, carbon dioxide gas is bubbled into freshly distilled water. Well, there are actually 3 acceptable answers for subpart 1 of this question. You can do the easy route. We've got carbon dioxide gas bubbled into water, and you produce carbonic acid. That's the part you got to know, H2CO3. You can also show this as ions. This, as you know, dissociates into a hydrogen ion and the bicarbonate ion, HCO3-. However, the most preferable, I guess, answer would be this, is that we know that hydrogen ion doesn't actually exist in solution. It forms hydronium by linking up with a water molecule, and the other product is still the bicarbonate ion. So this is the most preferable answer. All 3 are correct, but this is the one I think that you want to write in your answer box. Now, the second part of the question asks, the pH of the solution decreases as the reaction proceeds. Explain. Well, it should be obvious that we produce hydrogen ion, or hydronium ion, H3O+. So you can write H+ is produced, as the reaction proceeds, so pH decreases. And by the way, writing this for decreases, a down arrow, or up arrow for increases, is perfectly acceptable on the AP exam. Now the third subpart to this question states piece of zinc metal is placed in a 1 molar solution of hydrochloric acid. Well, you guys should know this reaction is zinc metal and hydrochloric acid is going to bubble. It's going to produce hydrogen gas and an aqueous solution of zinc chloride. However, there's a little balancing to do. You're going to need a 2 here to balance the hydrogens, and of course zinc chloride is a ZnCl2. Zinc is always a 2+. So when it comes time to look at spectator ions, chlorine is a spectator ion here. So the final answer written in the box should look something like this. Zinc plus 2 hydrogen ions. It's going to yield hydrogen gas and a Zn2+. The second part of this question says, all right, you put your piece of zinc metal, instead of 1 molar hydrochloric, you put it in 1 molar acetic acid, vinegar, or ethanoic acid at 25 degrees C. The rate of the reaction, the hydrogen gas bubbling, is slower than when you use hydrochloric acid. Why? Well, vinegar, ethanoic, or acetic acid is an organic acid. It is considered a weak acid. And if it's a weak acid, the concentration of the hydrogen ion is less than in a strong acid. And therefore, if the concentration of hydrogen ion is lower, the rate of the reaction is also slower. So the rate of the reaction depends on the concentration of the hydrogen ion. Oops, that should be say rate of the reaction depends on. And that is the answer to question number 4.